Hello, hi everyone. Welcome to the Student Brand, the brand new channel. So now we are going to discuss about light refraction. In the previous, so I hope you can observe the live class. In the live class, I explained completely about light reflection. So in this video, completely we are going to the light refraction. Light refraction. So I'll explain about light refraction. So you can check once. We'll work out on light refraction. In the previous video, the previous live class, you can observe the live class, so it will be there. So I explained completely about light refraction, light reflection. I explained in this class. I'll explain about light refraction. Light refraction I'll explain. Okay, so make sure that take a pen and notebook for writing whatever points we are discussing. So make sure that you are noting down. Okay, so because all important points we are going to discuss in this class. So hi everyone, this is your Seva sir from Student the Brand. So if you have any doubts in the previous live class about light reflection, so hi everyone, this is your Seva sir. Welcome to the Student the Brand. So if you have any doubts, previous live class, so whatever I explained, light refraction, light reflection, I explained complete light reflection. So if you have any doubts in that, so let me know. I'll clarify. I'll give some time to ask doubts from light reflection chapter. Light reflection chapter. I'll give some time. Then we'll work out on light refraction. Because see, it will take nearly 1.5 hour, 1 hour to 1.5 hour. It will take definitely the class. So make sure that you are attending the class until the end. So make a note of it. So take notebook and try to write along with me. Try to practice along with me. Now we are going to the complete light refraction topic. Light refraction topic. If you have any doubts, you can you can ask. If you have any doubts this on this chapter, so on topics, if you have any doubts on this topic, let me know. You can ask, you can comment, right? So now if you are taking, I'm taking the rare and medium. So this is the rare and medium and dense and medium. So rare and medium and dense and medium. Rare and medium, dense and medium. Speed of light is more in the rare and medium. Speed of light is less in the dense and medium. Okay, so when light is passing from rarer to denser, so I'm considering here if the light ray is passing from rarer to denser, this is a normal line. This is a normal line. If the light ray is passing from rarer to denser like this, so it bends towards the normal line like this. So here I'm considering this is a rare. This is a normal. This one is the normal, and this is the incident ray, incident ray, incident ray, incident ray, and this one is the refracted ray, refracted ray, refracted ray. Okay, so incident ray, refracted ray, normal, and the angle between incident ray and normal line is called angle of incidence. Angle between incident ray and normal line is called angle of incidence. So this angle of incidence, and angle between refracted and normal line is called angle of refraction. So here I am considering this angle of refraction, right? So angle of refraction, I'm taking this the angle of refraction. When the light ray is moving from rarer to denser, if the light ray is moving from rarer to denser, if the light ray is moving from rarer to denser, it bends towards the normal line. If the light ray is moving from rarer to denser, it bends towards the normal line. So why it is bending? Because speed is decreasing. So why it is bending? Because speed is decreasing. So at this point, at the point of interference, so when the light ray is moving from rarer to denser at the point of interference, so the light ray will bend towards the normal line because speed is decreasing. Speed is decreasing because speed is decreasing. Okay. So the angle of incident is greater than angle of incident is greater than, angle of incidence is greater than the angle of refraction. Angle of incident is greater than the angle of incident is greater than the angle of refraction, because when it is moving from rarer to denser, it bends towards the normal line. So the same case, if the light ray is moving from denser to rarer, so I'm concerned this is a normal line. Normal line. Light ray is moving from rarer to denser. Light ray is moving from rarer to denser, rarer to denser. So this is a rarer medium and denser medium. So light ray is moving from like this. Okay, so the angle of the angle between incident ray and normal line is called angle of incident. Angle between normal line and refracted ray is called angle of refraction. So when it is moving from denser to rarer, speed increases. Speed increases. Okay, so when it is moving from denser to rarer, speed. Okay, here in this case, angle of refraction is greater than the angle of incident. Angle of refraction is greater than the angle of incident. Here you can see angle of incident is greater than the angle of refraction. Angle of incident is greater than the angle of refraction. So by this we can conclude that when the light ray is moving from one medium to another medium, at the point of interference, the light ray will bend. Okay, so bending of the light at interference of the two media is called refraction, or we can say simply the path of the light changes. The path of the light, the direction of the light changes at the interference of the two media is called refraction. So the direction of the light changes at the interference of the two media is called refraction of light. Is called refraction of light. Is called refraction of light. So now we will go to the next one. What are the conditions for no refractions? What are the conditions for no refraction? When refraction does not takes place. When refraction does not takes place. So first point is when the light ray is passing, along the normal line. So if the light ray is passing along the normal line, so if you are taking this one, if the light ray passing along the normal line, no refraction takes place. No refraction takes place. Okay, no refraction takes place. And the second one, so the path of the light ray is if you are taking one medium and another medium. First, if the light ray passes along the normal line, no refraction takes place. And the second point, if the refractive index of two media is same, if the refractive index of two media is same, then no refraction takes place. So here I am considering light ray passes along the normal line. So along the normal line. And the second one, if you are considering light ray passes along the normal line, that is one point. The second ray, if the light ray is passing from one medium to another medium, so the refractive index of two media will be same. The refractive index of two media will be same. Then no refraction takes place. So these are the conditions for refraction of light. These are the conditions for no refraction. These are the conditions for no refraction. Next one, we are going to the one more. So one more I am considering here. I am taking. So the light ray passing from rarer to denser, denser to rarer will take. So I am considering here like this. So this is a rarer medium and denser medium considering here. Rarer medium and denser medium. Okay, so if the light ray is moving from denser to rarer, if the light ray, so I am taking here, this is a point. So I am taking this is one point. Okay, so I am taking this is one point. So if the light ray is moving from denser to rarer, what happens if the light ray is moving from denser to rarer? So at this point of interference, so generally it moves away from it. So this angle of incidence, this angle of refraction, So when the light ray is moving from like that, so the same light ray I am sending. So if you keep on sending the light ray, sir, when you will do numericals of this, we'll do numericals because for completion of chapter only it is taking time. So I'll complete this chapter, then I'll start doing numericals. Okay, Raswani. Today I'll try to complete the chapter. I'll complete the chapter because numerical it will take one or two numericals only. It will take full class. So that time we can't able to do anything. 1, 2, 3 problems only. It will take time. So that time, so we cannot get the product. Okay, so a productive way we can't able to do the class. That is the reason. First, let me finish the chapter. Then I will go for numericals. Okay, done. So I'm considering here. So like this. So this is the angle of incident. This is the angle of incident I'm taking. So if the light ray is passing like this, if the light ray is passing, okay. So at certain angle of incident, at certain angle of incidence, the light ray passes along the surface. The light ray gauges along the surface. The light ray gauges along the surface. So the light ray passes along the surface. So this angle is called critical angle. So the angle at which the light ray, the refracted ray makes 90 degrees with the normal line. The light ray passes from denser to rarer at a certain angle, So at a certain angle of incidence, the refracted ray makes 90 degrees with the normal line. So this angle is called critical angle. This angle is called critical angle. This angle is called critical angle. So if the light ray is passing, like this, so I am taking this a normal line. So at the point, when the light ray is passing from denser to rarer, at the light ray is passing from denser to rarer, so this is the angle of incidence. And okay, so in the rarer medium, it makes more than 90 degrees. So 90 degrees plus theta, it makes more than 90 degrees. Then the refracted ray reflect back into the same medium. Total light internally reflection takes place. So this is called total internal reflection. Total light internally reflection takes place. So this is called total internal reflection. Total light internally reflection takes place because in the rarer medium it makes more than 90 degrees, more than critical angle. So we can say critical angle. So that is the reason. Okay. So once again, critical angle we'll discuss. First point is critical angle. Critical angle is nothing but, so the angle at which critical angle. Second one, total internal reflection. Total internal reflection. Critical angle is nothing but the angle at which. Hi sir. Hi Sweta. Sorry. Hi Tanishka. Tanishka only, right? Yes. Okay, come to the point. So the angle at which, so here you can consider. Yes, sir. Hi Tanishka. So had your dinner? Yes. So okay, done. So this class will take time. So nearly 10 o'clock or until 10:30 it will take. So try to be in the class. Try to ask doubts. Yeah, just now I completed and came. Thank you for asking. So consider the light ray is passing from denser to rarer. So when if the refracted ray makes more than 90 degrees, then that light reflect back into the same medium. Then total light internally reflection takes place. So that is called the total internal reflection. So that is about critical angle and total internal reflection. Next one, we'll go to the next one. So I'll explain about lenses. Refractive index is there. Very, very important. Actually related to glass lab, they given questions in the previous board exam. If you check, they given glass lab diagram they given. So we will discuss the glass lab. I'm taking the glass lab like this. So it's a transparent medium. So we know the three objects. So one is a transparent, translucent, opaque. Here I'm talking about transparent medium. So the medium which allows the light completely to pass through it. So the light ray is passing like this. So I'm considering this a normal line. So this is a refracted ray. Again, I'm considering here is a normal line. Here is a very important topic from the chapter. Please tell according to you. This is very important. So this is very, very important. Make sure that you practice this one. If you observe from board exam, this question last year, Okay, previous last year also, this question they asked in the board exam. This question only. So directly they asked to draw the glass slab diagram. Okay, and explain about how the refraction takes place through a glass slab. That's enough. So simple diagram for 3 marks. 3 marks question. Tanishka. So here I'm taking if the light ray, if the incident ray, if you are extending, this incident ray, that is the initial direction of the incident ray. So the distance between emergent ray and extended incident ray, the distance between emergent ray and extended incident ray is called lateral shift. So this is called lateral shift. Lateral shift. Lateral shift. Lateral shift. Okay. So this is called lateral shift. If the light is curved, then so light, there is a property, right? Light has property rectilinear propagation, refraction, reflection, total internal reflection, like that. So it depends. Light always moves in a straight line path. There is a property of the light. Okay. So I'm considering here. What is your? Can I know your name? So actually, YouTube channel name is there. So if your name is there, we can call. Okay, done. Come to the points. The angle between the incident ray and normal line is called angle of incident, and angle between normal line and refracted ray is called angle of refraction, and the angle between normal line and emergent ray is called angle of emergence. Aswin. Hey Aswin. Hi. Welcome to the Student in the Brand. If you are new to the channel, subscribe the channel. So you'll get latest updations and live class. Anyway, at 9 p.m. every day, evening time, we'll be having live class. So join to the class. Okay, come to the point. So this is I'm taking air. So air, and this one is the glass slab. Glass slab. So glass slab I'm considering this air and glass slab. If the light ray is passing from air to glass, it bends at the interference of the two media. So if it is passing from air to glass, it bends towards the normal. If it is passing from glass to air, it moves away from the normal line. As so speed is decreases in the glass slab. Again, if it is moving from glass to air, so again it moves away from the normal line. Away from the normal line. Away from the normal line. So this is about refraction. So the angle, the distance between emergent ray to and initial direction incident ray is called lateral shift. Lateral shift, and there are 3 questions are there. Question number 1. Question number 1 is, so if you are taking the beaker here, so the person is here, the person is standing here. Okay, so coin is placed at the bottom of the beaker. So here from this position, from a position, the person can't able to see the coin. See the coin initially. So when you pour water, then what happens? So the position of the coin will rises up. So it will appear here. So the position of the coin will rises up. So I'm considering here the position of the coin will be here. Okay, so this is the actual position of the coin and this is the apparent position of the coin. So the distance between actual position to apparent position of the coin is called a vertical shift. Vertical shift. So lateral shift is the distance between emergent ray and incident ray. Initial direction of the incident ray is called lateral shift. The distance between actual position to apparent position of the object is called vertical shift. Very, very important. And a lateral shift depends on defending factors. What are the defending factors? Lateral shift. No, on what factor the lateral shift depends? On what factors, sir? It is due to refraction. Yes, due to refraction only. Because of refraction only, it will happen. So 2 more questions are there. Question number 2 and question number 3. I will explain. So those 3 questions will come for 3 marks. Like that, each question weightage is 3 marks. So that much important. So any question can come like that. I will explain those 3 questions. So now depending factors. So lateral shift depends on angle of incident. Lateral shift depends on angle of incidence and refractive index of the glass slab and wavelength of the light. Okay, So whatever the light is incidenting on it, so it depends on wavelength of the light. Whatever the light is incidenting on it depends on wavelength of the light. Once again, so first point is it depends on angle of incident. Lateral shift depends on angle of incident, and a lateral shift depends on refractive index, and a lateral shift depends on wavelength of the light. Lateral shift depends on wavelength of the light. Okay, wavelength of the light. So these are the factor depends. Okay, lateral shift depends on these factors. Once again, so angle of incidence and refractive index and wavelength. Okay, so next one we are going for if the coin is placed at this position, so the person can't able to see initially. After pouring water, the coin position rises up. So this is the actual position of the coin, and this is the apparent position of the coin. So the distance between the vertical distance between actual position and apparent position is called vertical shift. So if you take one more point, so one more point if you are considering, so you can take the beaker. So I'm considering the beaker. So if you take the beaker like this, so second point, beaker I'm considering like this. Okay, so if you place the pencil if you place at the point of interference of the water, so water and air. So water and air, if you at that point, so at this point the pencil will bend like this. So I'm considering here the pencil will bend like this at this point. Okay, so generally it appears here. Actually it is appear, so it is here, but it appears like this. It appears to be bent because of refraction only. Yes. So one example I will show you. So how it will bend. Okay. I hope it is. We can't able to see, but I will try. We can't able to see. I'll try. So will you able to see here? Will you able to see this water bottle? So I'm placing the marker back side of it. So will you able to see here? You can see. So little. So marker. So you see how it is. So it appears bulged like this. Yeah. So like that it happens. So that is by that we can able to see. Okay, so it appears to be bent. And next one more example. So third example is you are taking the lemon. Lemon is placed inside of the water. So I'm placing the lemon inside of the water like this. It appears to be bulged. So it appears bigger. So you can see in the shop, if you go to the shop, so if you they'll place the lemon inside of the water, so it appears to be bent. Okay, so it appears bigger. Yes. Okay, so that is about so these three questions are very important. 3 marks question will come for exam. So I hope it is clear to you. So next one I'm going to the next topic, lenses. Lenses I'll explain. So lenses I'm going to explain about lenses. Now you see. So there are two types of lenses: convex lens and concave lens. So I'm taking the convex lens. This is a convex lens. So optic center f1, 2f1, f2, 2f2. So because so it is a part of the sphere like this side, and here also it is a part of the sphere. Okay, so like this we are considering part of this sphere. If the light ray is passing, so this side circle sphere is there for that f1 and 2f1. So this side sphere is there, that for that F2 and 2F2 I'm considering. Now we can see one more I'm considering. So if you are taking the ray rules of convex lens, even for concave lens also same ray rules will use. Convex lens, sir, that is lens, right? Lens only. So I'm taking here, see, this is a lens. This one is the middle one is a lens. This is a lens. This is a convex lens. So I'm taking the principal axis like this. So here is the optic center F1 and 2F1. Here is F2, 2F2. So one light ray I am taking like this. After refraction it passes through focus. So that is the first one. Coming to the second one, another light ray is passing through it. Another light ray. So optic center F1, 2F1, F2, 2F2. So if the light ray passing through focus, after refraction it passes parallel to the, sir, I am getting confused with the lens and mirror. Ma, actually this is lens, ma. So if it is closed one is lens. So if normally if you are taking single one, this is the mirror. Like this, single one. So it is a lens. Okay, part. So no need to confuse, right? Simple only, right? This is the mirror, this one is the lens. Okay. Now, so another light I am taking. So through lens, I am taking the lens like this. Optic center F1, 2F1, F2, 2F2. So if the light ray is passing through optic center, so no deviation takes place. So it moves like that only. So we can understand. So these are the ray rules of convex lens. One light ray is parallel to principal axis, after refraction passes through focus. Another light ray passes through F1, after refraction it becomes parallel to principal axis. So if the light ray passing through optic center, so no deviation, it moves through optic center only. So that is about ray rules of convex lens. Coming to the concave lens. So I'm explaining about concave lens. Concave lens ray rules also same. I'm taking like this. So optic center F1, 2F1, F2, 2F2. So one light I'm taking like this. After refraction it passes. Okay. So after refraction it will diverge. Light rays will diverge. So it passes through focus. So second one, if you are taking second one. So I'm considering like this. So optic center F1, 2F1, F2, 2F2. So if the light ray passing through focus like this, after refraction it become parallel to the principal axis. And coming to the third one, so third one if you are taking, so third one, if the light ray passes through optic center, so optic center here, so F1, 2F1, F2, 2F2. So if the light ray passing through optic center, so no deviation takes place. So it continuously moves like that only. Okay, so this is about ray rules of concave lens. Next one, image formation by convex lens. So image formation by convex lens I will explain. Image formation by convex lens. So how we can go through the image formation? See here. If you are taking image formation, I am considering first image formation. So I am taking the lens. So optic center. So here is F1, 2F1, F2, 2F2. So one object is at infinity. Image will form at focus. So how, sir? So I am taking light ray like this. Another light ray I am taking like this. After refraction, those light rays will meet at the focus. Second one, so I am taking here. like this. So here is the optic center F1. So 2F1, F2, 2F2. So if the light ray, if the object is placed here, if the object is placed at infinity, image will form at F2, right? So nature of the image is real and inverted. Nature of the image is real and inverted. Size of the image is highly diminished because point size image will form at F2. Point size image will form at F2. Next one, I am taking the object beyond 2F2. Sorry, beyond 2F1. One light I am taking like this. So it passes through focus F2. So here I am considering one light ray, it passes through F2 like this. So another light ray passes through for optic center. So here is optic center. So this is F2, F2, 2F2. So this optic center. If the light ray passing through optic center, those light rays will meet between F2 and 2F2. So here is F2 and here the light rays will meet here. Okay, so I'm considering here object is placed beyond 2F1. Image will form between F2 and 2F2. Image will form between F2 and 2F2. Nature of the image is real and inverted. Size of the image is diminished compared to the object. Image size is decreased. So here image is decreased compared to the object. So once again, so here object is placed at infinity. Image will form at F2. So nature of the image is real and inverted. Size of the image is highly diminished. Point size image will form at F2. So one object is placed beyond 2F1. Image will form between F2 and 2F2. Nature of the image is real and inverted. Size of the image is diminished. Compared to the object, image size is reduced. So this about image formations. Next one, third one I will explain. Third image formations. If I place the object, third one you are taking. So third one, if I place the object, so I am considering here this is a convex lens. Optic center F1, 2F1, F2, 2F2. So if the object is placed at 2F1, image will form at 2F2. So here only image will form. So F2 and 2F2. So one light I am taking like this. It passes through focus. So another light I am taking through optic center. So that will meet here. So exactly at 2F2. Object is 2F1. Image will form at 2F2. Nature of the image is real and inverted. And size of the image is same size. Once again, if the object is placed at 2F1, image will form at 2F2. Nature of the image is real and inverted. Size of the image is same size. And coming to the fourth one, if you are taking the fourth one, so like this, optic center F1, 2F1, F2, 2F2 and 2F2. So object is placed between F1 and 2F1. One light I am taking like this. It passes through focus. So another light ray passing through optic center. Those will meet. Those will meet beyond 2F2. So once again, object is placed between 2F1 and F1. F1 image will form beyond 2F2. Nature of the image is real and inverted, and size of the image is enlarged. So here same size, here enlarged. So very important. Object is placed between 2F1 and F1. So image will form beyond 2f2. Nature of the image is real and inverted, and size of the image is enlarged. Size of the image is enlarged. Size of the image is enlarged. Coming to the next one. So if you place the object at f1, if you place the object at f1, so I am placing the object at f1. So here you can see. So like this, fifth one. So optic center f1 to f1, f2 to f2. So if the object is placed at f1, one light I am taking like this, it passes through focus like this. Another light it passes through optic center. Those light rays will meet. Object is at f1, image will form at infinity. Nature of the image is real and inverted, and the size of the image is highly enlarged because image will form at infinity. Once again, object is placed at f1, image will form at infinity. Nature of the image is real and inverted, and size of the image is highly enlarged. So this is about image formation. So next one we are going to the another one. Last case. So optic center f1 to f1, f2 to f2. So I am taking object here f1 and o. So one light I am taking like this. It passes through focus. Another light I am taking, it passes through optic center. Those light rays will meet at object is placed. Okay. So object is placed, right? So here I am taking. So these light rays you can see. So image will form here. So object is placed between F and O. Image will form same side of the object. So image nature is virtual, erect and enlarge. Compared to the object, image size is increased. Okay. So this is about convex lens. Here very important, this question they will ask for 3 marks. Next one we are going to the another one. Concave lens I'll explain. So only 2 cases are there. Optic center f1 to f1, f2 to f2. So object is placed at infinity. So here I am taking. So one light I am taking like this. Another light I am taking like this. So if you extend those light rays will meet here. Object is placed at infinity. Image will form at f1. Nature of the image is virtual and erect. And highly diminished. Because image is formed at f1. Image will form at f1. Nature of the image is virtual, erect and highly diminished. And one more case we are taking. So optic center f1 to f1, f2 to f2. So object is placed anywhere between infinity and optic center. One light I am taking like this. It passes through focus. Another light ray passing through optic center. Those light rays will meet between F and O. Object is placed between infinity and O. Image will form between O and F1. Nature of the image virtual, erect and diminished. Compared to the object, image size is decreased. So until here we will discuss. Next topic we will discuss in the next class. So until then, thank you so much. We will see in the next class.